Hello, I am Dr. S.K. TIWARI. Today we are going to talk on dating and its implications in correlation purpose. One of the important steps in stratigraphic study is to determine the time during which the rocks were deposited. The main aim is to understand about life, climate, conditions of deposition, etc. during the time when rocks were deposited. In fact, correlation is establishing the time equivalence of two spatially, that is geographically separated stratigraphic units. There are various methods for the determination of age. We have already talked about the radioactive method of age determination. If the absolute ages of rocks under study are determined totally with the help of radioactive methods, then the rocks can be correlated precisely or accurately. In addition to the above methods, various geological structures, presence of unconformities, and degree of metamorphism are also considered as physical evidence of correlation. We have already studied about the various radiometric dating techniques like potassium argon method, uranium lead method, rubidium strontium method, neodymium samarium method. Now we will talk about other methods which are fission track method, carbon-14 dating technique and thermoluminescence. The methods from 1 to 4 are used for dating older sediments up to Precambrians, while the methods 5 and 6, that is fission track and carbon-14 dating techniques, are more suitable for dating quaternary rocks. The C14 method is especially used for dating samples up to 50,000 years, but it is ideal for dating samples up to 20,000 years. Now we'll talk about carbon-14 dating technique. This technique was developed by Willard F. Libby of Chicago University in 1947. There are three isotopes of carbon: C12, C13, which are non-radioactive, while the C14 is radioactive. These three isotopes of carbon, that is C12 is present in the atmosphere only 1%. The ratio of C13 in the atmosphere is 99%, and the C14 is present in the atmosphere in a very less amount. The C14 is produced in the atmosphere by interaction of cosmic rays coming from the sun and nitrogen 14 present in the atmosphere. Thus, we can say that the ratio of carbon 14 and carbon 13 to carbon 14 is 10 to the power 12 is to 1, that is 1 trillion to 1, which remains constant in atmosphere. During their lifetime, the plants or the vegetal cover consumes carbon-14 by the process of photosynthesis. These plants in turn are consumed by animals and human beings. After the death of plants and animals, the C14 starts disintegrating and the ratio of radioactive and non-radioactive carbon decreases at some fixed rate. T-half, that is half-life of carbon-14, is 5,570 years. From the decay rate and the ratio of radiocarbon to normal carbon, the time of lapse after the death of organisms can be calculated. Thus, various parts of dead organisms like bones, wood, charcoal, marine shells or marine animals may be easily dated. An experiment can be performed to know the ratio of carbon-14 or to count the carbon-14 in a sample. The specimen is converted to carbon dioxide by burning it in presence of oxygen or by the action of acid on carbonates. The carbon dioxide is reduced to carbon and the amount of radiocarbon is then measured by a Geiger-Müller count method. The material which is to be dated should be sent to a very equipped laboratory. Then the sample is split from a block of wood. This broken sample is then placed in a heating tube at beginning of the process of converting it into carbon dioxide. The sample is burnt in a tube. The reaction is started by a torch and continued by using an electric furnace. The carbon dioxide from sample is then dried by freezing and stored. Then finally, with the help of Geiger-Müller counter, we measure the amount of radioactivity in the carbon prepared from the sample. Like other methods, also this technique has its own suitability and other sources of error. This method is suitable for or well applicable for the dating of archaeological or prehistoric specimens. But this technique is not suitable for dating ancient geological specimens. There are also some sources of error in this technique. The carbon-14 of the atmosphere is diluted due to the combustion of coal, oil, petrol and diesel, etc. The carbon-14 is also produced as a byproduct of missile testing and its abundance has increased by about 1%. The carbon-14 in the content of atmosphere have varied very significantly in the last 6,000 years. Now we will talk about paleomagnetism. This method is applicable for dating quaternary rocks, but can be used for dating rocks up to tertiary age, that is up to 65 million years. This method is ideal for dating Miocene rock sequences up to 25 million years. This method is also helpful in developing a paleomagnetic scale. Another method is chemical method. There are various types of chemical methods, which are amino acid method, obsidian hydration method, and tephrochronology method. The methods of dating are very useful for samples up to quaternary period. The tephrochronology is applicable up to the tertiary period, that is 65 million years. There are also biological methods. In the biological methods, they include biochronology, lichenometry, and dendrochronology techniques. These methods are useful for dating quaternary samples. Now, the geological age may be absolute if the dates have been taken by the radiometric technique or relative in nature. The relative ages can be established through application of some principles which are very simple and universal in nature. These are law of superposition. This law states that the older rock formations lie at lower part while the younger formations lie at the top of the sequence if not disturbed. The second law is law of initial horizontality. The rock formations are initially deposited horizontally and are not folded or faulted. Later tectonic activity may change their pattern of horizontality. The third law is faunal and floral succession. This law states that the older or primitive life forms are found in older beds, while the modern forms are found in the younger rock formations. The fourth law is cross-cutting relations. With the help of various geological structures like faults, unconformities, and igneous intrusions like dikes, the older and younger beds can be differentiated. The fifth law, which is based on the sedimentary structures, states that on the basis of certain structures, for example, the presence of soul moths, which are present below the bed of sandstone, the younger and older beds can be identified. Now we will talk about the correlation part. It is concerned with the mutual equivalence of organisms or rock units. The rock units may be equivalent in some aspects. Some of them are time, mythology, fossils, and climate. All these aspects can well be observed in deep sea pools. The main objective of correlation is to develop a geological scale or to interpret geological history of a region. Correlation is influenced by magnitude of features and distance. There may be various evidences of correlation which can be categorized into physical, paleontological, and metamorphic, which has been shown in Table 1. The Table 1 shows the evidences of correlation based on physical or sedimentary rocks. These are lateral continuity of beds or formations, lithological similarity of beds or formations, sequence of strata at two or more locations, rhythmic sequence, for example, presence of warped clay in Karawa series of Kashmir, cyclothenes presence in Gondwana supergroup, the presence of stromatolites in Vindhyans, geostatic changes in sea level, key beds or marker horizons, like the presence of ash beds and bentonite beds, the radiometric age, the paleomagnetism, the seismic reflection profiling, which is also known as sonic stratigraphy, or acoustic sonic profiling, or electric or radioactive logs, or isotopic stratigraphy using oxygen, carbon and carbonate, or graphical correlation methods. These are the evidences of correlation based on metamorphic rocks for the Precambrian time. These include change in lithology, order of superposition, absence of fossils if not obliterated by metamorphism. Another evidences of correlation is based on paleontological evidences, which includes range zone, concurrent zone, Ekmes zone, phylozone or index zones, added with some other evidences like quantitative biostratigraphic method, stromatolites, tracing evolutionary ages of fossils. Now, what do you mean by index fossils or guide fossils? These are very useful for interregional or intercontinental correlations. In the index fossils or the guide fossils should have a very wide geographic distribution but should have a very short geological range. They should have ecological tolerance. They should be abundant. They should have rapid evolutionary rate, and they should also have distinct morphologic features. Now, the biozones represents all rocks throughout the world that were deposited during the time interval in which a species survived. No species is present in all the rocks of its biozone. The assemblage zone, we know that there is more reliance on more than one species for accurate correlation. Most biostratigraphic zones are based on occurrence together of two or more species, which are known as assemblage zone. Now, what do you mean by type sections? These are local stratigraphic sections. The type area is defined as an area where the system was first recognized. For example, Triassic or Spiti Valley in Himachal Pradesh, India. The above said evidences can be observed in the following, like stratigraphic sequence, lateral continuity, structural relationship with igneous intrusion, associated ore bodies of epizootic origin, lithological composition, chemical composition, grade of metamorphism, radiometric dating, electric and radioactive logs, stromatolite presence, paleomagnetism, isotopic changes, geostatic sea level in Mesozoic and Tertiary era, and concentration of iridium. Now, there are various methods of correlation. Some of them are physical methods, chemical methods, and biological methods. The physical methods include paleomagnetism and magnetostratigraphy and marker Bates method. The chemical methods include amino acid method, obsidian hydration method, and the method based on tephrochronology. The biological methods include dendrochronology technique and the technique based on lichenometry. The first one is physical method, which includes paleomagnetism and magnetostratigraphy. This technique was evolved in the year 1950. It is a very new physical method of correlation. This type of correlation is based on the study of paleomagnetism of Earth. That is, we can say that the method is based on the study of magnetic properties of rocks. Cox in 1969 for the first time established a geomagnetic polarity time scale for the last 5 million years. This method has now become almost equal in importance to biostratigraphy and radiometric dating in establishing a time scale for the last 30 million years. Advantage of polarity reversal sequence to stratigraphy is that the reversal is synchronous worldwide. This fact has been utilized for the stratigraphic correlation. This method can be used in two ways for correlation purpose. They can be used to correlate local sections, for example, correlation of symbolic sequence of Himalaya. They can also be used to correlate local sequences or sections with global chronostratigraphic scale. The another method is based on the presence of marker beds. The sedimentary beds, which were deposited over a very vast area in a very short time range, are more useful for correlation and are known as marker beds. For example, the coal seams, bentonite clays, ash beds, etc. If correlation of at least one of the beds in a sequence is to be correlated, is done with the help of marker bed, other beds can be correlated in relation to the unit whose correlation is already established. Now, chemical methods, which includes the method based on amino acids. By this technique, we can estimate the age of associated inorganic deposits. Also, we can estimate paleotemperature of organic samples of known age. We can also date the age from few thousand years to few million years. Another technique is obsidian hydration method. It encompasses a number of methods which assess or estimates the amount of weathering that an inorganic sample may have experienced. Method is used to estimate or assess the relative age of episodic deposits such as moraines, till deposits, etc. Obsidian. These are glassy products of volcanic activity which are formed by rapid cooling of silica-rich lava. This method is based on the fact that a fresh surface of obsidian reacts with water which is present in the atmosphere and forms a hydration ring. The thickness of the hydration ring can be used to date glacial events if obsidian has been incorporated in glacial deposits. Another method is method based on the technique of tephrochronology. During the volcanic activity, the ash and volcanic dusts are produced and these are preserved in ocean beds, which have been proved by the DSDP records, that is the Deep Sea Drilling Project records. During explosive eruption, a blanket of tephra, which is fine dust or ash beds, covers a very large area. Thus, they form a stratigraphic marker. The ash beds can be dated by potassium argon or fission track method or indirectly by radiocarbon dates or organic material above and below tephra layer. In favorable conditions or circumstances, the deep sea deposition, these organic material incorporated within tephra layer may provide quite precise time of the eruption event. The another type of method is biological, which includes the technique based on dendrochronology. This method is applicable for samples younger than Cambrian age. This method deals with the study of growth rings. This technique provides information mostly about climatic changes, and the method is very accurate for 1000 to 2000 years, but is less important and hence not widely used. However, the method is basically used in two ways. Number one, to provide the minimum date for the substrate on which the tree is growing. Second, to date an event which disrupted tree growth but did not terminate. In recent years, the radiocarbon dating technique of tree rings has opened new area of research which is known as dendrochronology. Thus, this method gives a precise dating of tree rings and also changes in concentration of carbon and nitrogen in the atmosphere. Now we'll talk about the uses of fossils in correlation purpose. The fossils provide a much reliable tool for stratigraphic correlation. The index fossils and zone fossils are frequently used in correlation. Such fossils are characterized by distinct morphology, their vast population, quick migration, capacity to thrive in any environment, very wide distribution in space and limited distribution in time. Thus, their presence is expected in rocks worldwide, which were deposited in a very short time interval. If the formations contain identical index fossils, same formations can be taken as belonging to same age. There are three types of fossils in any fossiliferous sediments. These are known as index fossils, cosmopolitan fossils, and local or endemic fossils. Now we'll talk about the various techniques for dating the ice cores. For the dating of ice cores, many different approaches have been used, and it is now very clear that accurate time scales can be developed for the last 10,000 to 12,000 years. For example, the ice formations of Antarctica can be dated. Prior to the different methods of dating ice cores, there was uncertainty about ice ages. Various methods can be used for dating the ice cores. These methods include radioisotopic methods, which include lead 210 isotope method, silicon 32 and argon 39 method, and C14 method. The lead 210 isotope method can date up to 150 years. The silicon and argon isotopes are used for dating up to 1000 years, while the C14 technique can be used to date the ice cores up to 25,000 years. The delta O18 fluctuation technique is helpful in dating samples up to 15,000 years. The microparticles can be used to date the samples up to 10,000 years. In addition to this, the seasonal changes in the trace elements, like the changes in the proportion of sodium, calcium, magnesium, aluminum, can also be used for dating the ice cores. In addition to this, the presence of volcanic dust or ash can also be used for dating of ice cores. Now, we'll talk about the various methods of dating Pleistocene rocks or samples. There are various methods to date samples up to Pleistocene. These are potassium argon method, rubidium strontium method, carbon 14 dating technique, palladium 231, thorium 230 ratio technique, ionium excess method, paleomagnetism method, cold and warm water foraminifera as indicator of past climate, ratio of O18 to O16 of calcium carbonate test or shale of organisms, the pollen proportion, and the percentage of Arctic and Antarctic diatoms. Now we will try to understand the correlation of different type sections of different geological systems of different areas through a sketch or diagram. In this diagram, three type sections have been taken. These are type section A, type section B, and type section C. These three type sections have been used to develop a vertical scale based on time rather than on sediment thickness. So with this, now we are going to conclude this lecture, and thanks and have a nice time.